Hello everyone. In this video I want to show you how to work with the soil plugin in QAquifolium. So the system we're going to try to model is consists of a catchment. It's a kind of a small 100 has to be 100 square meters. Sorry, 100 meters. That's a mistake. So it's 100 square meters area catchment, and then we want to basically model. Of course, we're going to have precipitation over the catchment. And then we're going to look at infiltration into the soil to groundwater. And then, of course, the excess runoff that will not infiltrate to the groundwater will generate surface runoff that will go to a kind of a receiving water that we're going to assume is going to have a fixed head. So for this example, I'm gonna assume the groundwater table is first of all is fixed. Its head is not affected by infiltration, and the groundwater table is 1 meter deep. So we have an unsaturated or vadose zone depth of 1 meter, and we're going to set the elevation of the surface of the catchment ground surface to be 0. And then that's pretty much it. And then I'm going to use some precipitation data that I have from you know I've generated it for somewhere local. I'm going to use it for this example. So let's get started. So here's Aquifolium, the graphical user interface for Aquifolium. So what I'm going to do is, first of all, let me load the soil plugin. So what I'm going to do is that I'm going to go to Preferences. I'm going to click on Add Plugin. And then I'm going to look for, in my case, my plugins are in this folder, and I'm going to look for unsaturated soil, and I'm going to load unsaturated soil plugin. So when I do, I'm going to get one additional block called variably saturated soil block, and then I'm going to get a few connectors that are for connecting the soil block to other components. Okay, so the first thing we're going to start with is let's create our catchment itself. So I'm going to use this catchment component. Let me just reshape it. So then I'm going to provide some parameters. So I'm going to provide a Manning roughness coefficient, because we're going to need that. Let me expand this window a little bit so that we can read the properties. Okay, a little better. Okay, right there. And then I'm gonna take care of precipitation later on. Catchment slope, let's say the catchment slope is 1% too. Initial storage, I'm going to leave it at 0. The width of the catchment, let's say it's a 10 meter by 10 meter, pretty small catchment, but this is just an example. And then so catchment area is going to be 100. A mean elevation of the catchment, I'm going to keep it at 0, and that's pretty much it. So we have the catchment. Now, next thing, let me add precipitation, by the way. So what I'm going to do is that I will just add a source, a precipitation object, and then I'm going to specify this file that I have. So I have my precipitation data right here. So this is precipitation data from 2010 to 2012 for somewhere, I think it should be from Baltimore International Airport. So I'm going to open that. Now if you want to look at the precipitation, I can just right click on this precipitation item and then look at the precipitation. So as you see, we have data from January 2010 to January 2013 actually. So then I'm gonna apply this precipitation. So we have, for the catchment, we have this property called precipitation time series, and I'm gonna just select precipitation 1 for that. So that precipitation is gonna fall over this catchment. Now let's do the soil. So for the soil, what I'm gonna do is that I will just create one soil block, and then I'll make a copy of it. So I'm going to add one soil block right there. Now, as you can see, we have, if I move to we have 5 soil blocks right here. So we have 1, 2, 3, 4, 5. and the depth is 1 meter. So each soil block is going to be 20 centimeters deep, right? So so depth of the soil block, I'm going to say 0.2. The saturation hydraulic conductivity, I'm going to increase it to 0.1 to get some, more interesting results. Because if I keep it at 1, I'm not going to get any surface runoff. The area, let's talk about the area. So the area is going to be 100. The bottom elevation is going to be minus 0.2, right? And then you see I'm going to keep all the properties of soil. So we have this saturated moisture content, which I'm going to keep at 0.4. Residual moisture content, I'm going to keep it at 0.05. Specific storage and so forth. Van Genekton parameters. There are some default values that I'm going to keep. Now, one thing is that I need some initial storage. So what we have is we have 100 square meters area, and the depth is 0.2. So here we get 20 cubic meters, and then the saturated moisture content is 0.4. So 20 times 0.4 will give us 8, right? So 8 cubic meters is the total storage, the maximum storage in this soil. I'm going to assume that the effective saturation is half of it. So I'm going to start from an initial storage of 4, right? So 4 cubic meters is our initial storage. And that's pretty much it. So we have pretty much our first soil block created. Now what I'm going to do is I'll just make some copies of it. So I'm going to copy it, and I'm going to paste it here. And I can keep on, basically, yeah, I'm going to copy again, paste. So that's 3 soil blocks, copy again, paste. And then copy again and paste. Okay, so we have 5, and the only thing that I need to change, assuming that the soil is homogeneous, all the properties of these blocks are going to be the same, with the exception of the bottom elevation that we need to change. So for the soil 2, the bottom elevation is going to be minus 0.4. Oh, I'm sorry, minus 0.4. For soil 3 is going to be minus 0.6. For soil 4 is going to be minus 0.8, and for soil 5 is going to be minus 1. Okay, so then the other thing is that I need to connect these soil blocks. So basically, the first thing is that I'm going to connect the surface water component, the catchment, to soil. So for that purpose, I'm going to use this this link called surface water to soil connector. So I'm going to click on that one, and then I'm going to connect. And then for soil blocks to each other, I'm going to use a soil to soil connector, right? So I'm going to click on that soil to soil connector, and then I'm going to connect these. I have to make sure to click on it every time I want to add a new connector. And then the last one. Okay, now let me save my model. I'm going to save it as, let's say infiltration 2. Okay, now we are, okay, let's do this. I'm going to now run the model and see what happens. Okay, so what happens is that we don't have any drainage, so all the water fills up the soil column, and then we should get some sort of a flooding or ponding of water on the surface, because we don't have any way to kind of get rid of the water that is being accumulated in the system. So, but that's fine. We can just look how things are going and whether we did things correctly. So I'm gonna run the model for 1 year. So I'm gonna go to settings, general settings, and then if you look, for some reason the top property is simulation end date. So I'm gonna make simulation end date to be January 1st, 2011. And then I'm going to get simulation start date is going to be January 1st of 2010. So that's our 1 year. Let me save it and let me run this. It's going to take a little bit of while. And done. Okay, so let's see what's happening. So the first thing, let's look at the infiltration. So I'm gonna right click on this link connecting the connecting catchment 1 to soil 1, and then I'm gonna look at flow. So this is what you see. You see you have some flows at the beginning, and it'll go to 0, and the reason for that is our hydraulic head in the soil will start increasing, and the soil will start basically saturating. So if I look at, let's say, the theta, which is moisture content, you'll see that it will get to 0.4 and it will increase, right? So that means we have a positive head. If I look at the water depth on my catchment, you'll see that at one point it'll start rising up because the precipitation water will not infiltrate to the ground, and therefore we have ponding over the catchment, right? So now to resolve this problem, we need to somehow allow the water to infiltrate from this soil 5 to the groundwater. Now what I'm going to do is that I will use this fixed head boundary condition essentially to represent the groundwater, assuming that the groundwater depth is, or groundwater table is fixed, it's not affected by the amount of infiltration. So I'm going to add this fixed head block. Just then the head is going to be, you see this default initial storage. That's a good thing because I want to make sure that I have adequate water in my fixed head boundary in case we have some upwelling due to the fact that the hydraulic head in the soil may be less than our groundwater table. But then the head, I'm going to fix it at -1, right? So we'll fix the head at -1. And then we have this this block that is called soil to fixed head connector, and that's what we need to use. So what I'm going to do is that I will just select that one, and then I'll connect these two, and I'm going to save it. And let's now run the model again and see what happens. So I'm going to run the model. It's going to take a little bit of while, maybe around, I don't know, 30 seconds or so for a 1-year simulation, which is not too bad. You can also look at the simulation details to see what's going on. This is our time step. Okay, I'm going to hide the details. Okay, it's done. Actually, it took a little more than 1 minute. So I'm going to close this. Now let's look at some of the results. So now let's see if I have any ponding. So now I have a lot less. So basically I have some incidents where I have a little bit of ponding happening on the catchment because the infiltration capacity is less than precipitation intensity, but the results are much more realistic than before. I can look at the infiltration flow. So this is the infiltration flow that we have here, and we can also look at maybe infiltration or percolation down here, and that's what you have. You have a negative infiltration, and that's because of the fact that our soil was relatively dry at the beginning, so we have sort of upward flow of moisture, but that's what we get. Okay, so that's the infiltration model. Now the next thing I'm going to do is that I will let's add this receiving water, and I'm going to use a fixed head for the receiving water as well. So let's just I'm going to just use, to make things simple, I'm just going to use the fixed head again. So now you can have, in your case, you may have a stream, or you may have a pond, or any other thing as a receiving water, and then the model may continue in, basically the flow may go into a stream network and so on. But I'm going to just stop it at this point, and then I'm going to consider model my receiving water as a fixed head. So the only thing is that for the fixed head, I'm gonna fix the head as, let's say, it doesn't really matter, but I'm gonna fix it at minus 0.1. So assuming that this receiving water is 10 centimeters below our catchment, and then I'm gonna use this connector. This is called catchment link, to link my catchment to the fixed head, and it doesn't have any properties, so things should be fine. Now I'm going to save it, and I'm going to run the model again. This is done. Close the run window, and now I can look at how much runoff was generated, essentially by looking at the flow in this link. So as you can see, we have 2 incidents where we have some surface runoff, or actually 3. The third one is quite minor. And then I don't know. You can also look at the moisture content in the soil. So let's look at theta, and you can see that sometimes it gets close to saturation, doesn't get to 0.4. I think if I look at this bottom block, I'm going to see, it's much closer to the saturation. Sometimes it may go above saturation. And then I can look at maybe the storage, how much water infiltrated. So you see, we lose a little bit of water at the beginning because of this upward flow, and then we have an increase in the storage. So this is how much water infiltrated into the groundwater, and total amount of water going into our receiving water. You can look at it. So we have 2 events where that happens. So that's it for this one. Please look for my other videos on Aquifolium, and have a great day.